Hi, hello everyone. So today we'll be going to talk about the new vLLM feature that was implemented recently. So let's talk about what's the problem it solves and what's the feature it brings along. So previously, like whenever a model is built, usually for building and training the model, we'll be using transformers architecture. But the transformer architecture won't be optimized to run on vLLM for the inferencing. So because inferencing is something we need to do it fast, right? So users don't have to wait for a long time. So there are lots of optimizations that LLM has done on its own side, mainly for attention uh, layer. So previously, so once the model is built in the transformer, we will be like the people will be like rewriting it in vLLM. Like basically, it's like a custom vLLM support models. So this was like kind of a two times effort, right? We need to write it in once for training, again for inference to be running optimally in the vLLM architecture. So that was the pain point we had. But now vLLM has come up with a new feature where we don't have to rewrite anything when we want to do inference. The same transformer model that we built on vLLM transformer will be auto optimized by the vLLM. So what vLLM does? Okay, let's deep dive into the blog, which was in the Hugging Face. So it will be very much clear on what we are talking about. This is just overview. Yes, let's go into the actual architecture now. So this is the blog uh, which is explaining that particular change. So as I mentioned, we'll be walking through how vLLM is able to achieve that. Skip the custom rewriting part, which was taking a lot of time. So basically, the new benchmark, they also benchmarked it against the custom models that was built for vLLM, which is the own optimized version, just auto, which creates like automatically via vLLM package. They benchmarked it, and basically this one actually up to the mark to the same benchmark of the custom model, or sometimes it exceeds the in terms of benchmarking performance. So this will be kind of a go-to thing going forward. We can skip writing the custom models. So let's walk. Let me walk you through the things. Um, yeah, just to reiterate again. So transformer VLM backend is quite currently is faster than the custom VLLM. We know why we had to write custom VLLM. Basically, to make transformer architecture faster on VLLMs during inferencing. But going forward, it's not needed because Hugging Face provides this transformer VLLM backend. So we just have to how to use it. We just have to do. We just have to upgrade the VLLM package and then torch backend to auto. So once we did that, the new changes will be coming along, the new PRs, whatever they did. Um, so this supports like 450 plus architectures. So basically, it supports all these frameworks, SGLang, VLLM, and things. So basically, to showcase the benchmark, they have tested it on Quant 3, 4 billion, 32 billion, and also like even bigger model. Also, like while deploying directly with vLLM, we can in the while doing a vLLM, so we can have these options. Like for the smaller model, just say model implementation transformer. So it will basically auto optimize the things for us. Let's say model is little bigger. Then we for 32 billion parameters, we will use tensor parallelism. Basically, there are mainly four different optimizations that we'll be doing. We'll be going through that in the like bottom of the blog going forward. So let's say for even bigger, like 235 billion parameters to make it optimal, we need to make sure the data parallel size is 8. You can see it here. And then for the parallel run, there is expert parallelism. We need to enable that. So once we are able to do that, the what was this the previous versus the current one? You can see it's like you can see the improvement. Drastic improvement was there compared to the custom VLM models. Yeah, these are the example of how to basically configure and run it. Yeah, so what's new? So previously, as you know, that whenever a new model is created, they use transformers to train it, then they rewrite in vLLM. So it was like a two times effort. So now going forward with this change, there is just a one model. We train it with transformers, and then with same thing we directly use it on vLLM. So there is no two different models we have. So let's also see how this is done later in the blog. So yeah, so here we will be talking about how that works. So how it works is we use torch.fx. So whenever we do a torch.fx, this is kind of how we are going to read a model. Models are nothing but the mathematical derivations, right? So how we are going to read it. So whenever we do torch.fx, so this is helping us basically to see what is in the model and basically to read it. Not just that, we also read the whole flow of the model, like a end-to-end kind of a overview and the whole detailed flow using abstract syntax tree. So with the AST tree, we can basically go understand the entire model. We can even so because during transformer we might have written a module in a way which will be more efficient with the vLLM. So vLLM automatically use torch.fx to see the code and then also see the relationship using AST and then automatically kind of upgrade the code. There is no manual intervention here. It automatically reads it and it has like sets of rules. Whenever some of the rules hit, it automatically optimizes that part of code and then it just kind of add it to the existing AST tree. So it's kind of a rewrite, but automatic rewrite based on some set of rules. So that's what is happening here. So what they are achieving through this. So there are like a couple of optimization we do. So generally people talk about the attention level performance improvement. So that's the existing one. So currently like vLLM has its own optimized version for doing the attention during inference layer, whereas the transformers attention is like not good compared to vLLM. So we generally we replace vLLM's attention framework on top of the transformers one. So we just replaced with the vLLM attention for inference. So that was the major optimization that people are doing before. Now we also do lots of other optimizations. I'll be walking you uh, some of the ones. So like maybe one of it is uh, upgrading the CUDA graphs. So what happens is, let's say previously we were running like what simple operations inside the kernels using CUDA on NVIDIA GPU, right? So let's say now we feel um, like now the optimization is like instead of running like individual uh, functions, like functions are nothing but kernels, right? So instead of running the individual functions on GPU, it will basically understand the flow using the AST tree and rewrites it. So we can run more parallel functions. Some of the simple steps it can combine together into a single kernel function. So it will be quite fast. So all these things will be done by vLLM model. Um done by vLLM model in a more optimized way. So let's maybe we can name the point. The point one, if you want to remember, is rewrite the kernel functions instead of single simple functions to a more. We can combine multiple simple functions into a single one. So it's faster. That's the one thing. The other thing will be like parallelized GPUs. So instead of running on like individual GPUs, we try to parallelize it. Again, for running that, do a parallelizing work, we have like a couple of different models, different types. So depending on the kind of work or depending kind of the module that's going to run, we either do we can have multiple GPUs running having the model in parallel and running it together, or we split the task parallelly. So basically, they have their own different types of ways to run it to increase the parallelism. So this will be kind of done automatically again. So yeah, that's one of the thing that we do. Um, yeah, so these are some of the optimizations that there will be like the kind of auto calculator, basically auto written. It will kind of rewrite the existing transform model during the vLLM inference, and then it will run it efficiently. So we don't need to write custom code any of the time. So going forward, whenever we are going to use a model, existing model in transformer, going to deploy, we don't need to write any custom models. We just have to use this, use the upgrade vLLM, and then just use the latest one, so it will take care of the things. Just that make sure to use different configurations based on the model size. Yeah, that's pretty much what I wanted to say today. I was like a bit excited to know about this news. So yeah, hopefully it was to help people with their everyday work. Yeah, thanks everyone. Bye.